Greetings. This is a short video about sheet folding theory and technology that has been developed at Rutgers University. It has been supported by many agencies including LIA, so we begin by saying one of the applications of this technology is the airdrop, free airdrop. You design a sub bag. The cushions are installed inside the sub bag, as you see. These cushions are produced based on the theory of sheet folding. Once you put the cushions in place, you place the items to be dropped, put a lid, cover them, and you are ready for the airdrop. We can test this for different applications such as ammos, MREs, and others. Let's explain how the process begins. It starts with a flat sheet of material, usually a roll of paper, is fed through a series of rollers that will advance and continue to fold until the desired width is produced. Finally, it is fed into the folding pattern that is fed over a tank of glue. The bottom of the folded material has glue. Then a laminate is applied from the bottom, and when the material is finished, it passes over a conveyor, and then it goes fed into another system underneath it that will determine the length of the material to be cut based on the cushion design, and passes this above a layer of another glue and stacks these cut pieces to form a pad. Once the desired number of pads are produced, they're ejected one at a time, and you can assemble the box as we have seen earlier. Here's further details. You can see here the big roll. Papers are fed so that we have a crowned roller to maintain paper in the middle. It goes through the first set of folding. As you can see here, one groove like fit in the one next one with 3, 5, and it's mathematical series, as you can see it here. These are called pre-gathering rolls until the desired width has been achieved. These are essentially longitudinal folds, as you can see it here. As they advance, they go to the last set of rollers that will produce the desired pattern, and this is will fold the material as you see it here. It's called forming rollers, but really no forming, it's folding. And here's the folded material for the core. When it leaves the machine, it passes over a roller with the glue. This is the laminate, comes from underneath. The material from laminate is then placed on the core is placed on top of the material. They're pressed by a conveyor, as you see it here, so to allow the adhesion between the core material that's folded and the laminate to hold. It then advances on top of the conveyor. It's released in the other end. Then we build enough buffer to feed the material to the next stage, which is simply cutting to length. You can see a sensor is moving. The sensor will move to a location depending on the length of the material to be cut for the cushion size. Once that set in position, the roller feeds in the material, as you see. Then it will hold in place, and a cutter will come down to cut the piece to the desired length, as you see. Then a stacker will come and lift that piece, passes it over another glue tank where a glue is applied in the bottom of it, and this is the glue tank, and then it's tagged. The process is repeated until the desired thickness of the cushion is achieved. That thickness has been determined beforehand based on the type of material to be dropped, the altitude and the speed of aircraft, and fragility of the item to be dropped. Of course, the machine is flexible enough to design any size cushion depending on the material to be dropped. This is another close-up of the stacking glue contact. You can see that glue is hanging down there, and this is how it stacks. Once the desired thickness is achieved, it will be ejected. The whole cushion is ejected and labeled to let the user know it's going to be a side piece or a bottom piece or a top piece and so on. So the instruction for the assembly becomes very clear. As you can see here, the finished pad will be ejected and ready for assembly. Well, you can implement that right away for airdrop, as we have done here. Varieties of material can be dropped with different altitudes, different airspeed. Other applications of this technology include folding different type of material, such as plastic, for example. If you preheat the material, the plastic, you can fold it to a pattern you require, as you see it here. And we can create plastic pads, we can create pallets. This can also fold metals, such as you see here. It's copper. You can use it for furniture. You can fill in a frame with paper, put a laminate on top, as you can see it here.